This will be for the con assignment, types of statistical studies. A pharmaceutical company wanted to check whether their new cough medicine, Serenity, really relieves coughs. To do that, they went over medical records of all clinics in the country and looked for an association between the type of medicine prescribed for patients who suffer from coughs and the level of their recovery. Which type of statistical study did the pharmaceutical company use? So for the types of studies, the three choices are sample, experiment, and observational. Okay, in a sample study, you basically test or survey a portion of the population. All right. In an experiment, you test one group and the other group gets a placebo. A placebo would be like a fake version of whatever you gave to the one group, like an aspirin pill or a drink or something along those lines. Okay, and an observational study is basically what it sounds like. It's when you just sit back and observe. So in this case here, they did not administer the medicine to one group and then have the other group get a placebo. Okay, so it's not going to be an experiment. Okay, and it's not a sample study, because a sample study is when you only test like a portion of the population. All right, and that's not what happened here. Here they went over medical records of all clinics in the country and looked for an association between the medicine who suffer from coughs and their level of recovery. So they didn't manipulate anything. They just sat back and observed. All right, they went over the record, so it's observational. Follow-up question, is the study appropriate for the statistical questions it's supposed to answer? Well, they wanted to see if their new cough medicine, Serenity, really relieves coughs. That's the question they wanted to answer. So the problem here with using an observational study can't determine whether the medicine caused the people to stop coughing. Okay, in order to see if the medicine really caused the people to stop coughing, you would have had to do an experiment. Okay, and you'd give the drug to one group of people, and then the other group of people you'd give a placebo. That's the only way to see if the medicine works, to do an experiment. For observational study, you can't use that type of study to determine cause and effect. All right, so it's not A, because they're asking us, is this study appropriate? And it's not yes. All right, and it says didn't choose clinics at random. That's not true, because the type of study isn't appropriate for the question. That's it right there. Okay. So looking at their answer, sample study is when you estimate a certain parameter of the population. Observational experiments is when you compare two parameters. All right, in an experimental study, one parameter is actively changed to see the effect on the other parameter. Okay, that's not what happened here, so this was observational. The company didn't choose clinics at random. They collected data from all clinics. All right, we said that. And right here, an observational study cannot indicate a causal relationship between parameters. Okay, so for an observational study, you cannot have cause and effect. Okay, so remember that for observational study, you cannot do cause and effect. All right, so that's why the study doesn't allow us to assess the actual effect of the drug Serenity, the medicine. Right here, any correlation between taking Serenity and level of recovery isn't necessarily an outcome of the medicine itself. All right, a research institute interested in factors that can either cause cardio disease or prevent it, conducting a long-term study of the 5,209 people of Framingham, Massachusetts. Study included extensive physical exams and lifestyle interviews performed every 2 years, which were analyzed for common patterns related to cardiovascular disease development. Okay, so it looks like they studied all of the people in that one town or city. Okay, so it was not a sample. A sample is when you only do a portion of it. All right, and an experiment is when you give the drug or test to one half and not the other half. All right, and that's not what they did here. So again, this is an observational study. And I can tell you already, since it has the word cause here, that it's probably not going to be an appropriate study, okay? Because we said it before, observational study cannot do cause and effect. And they're trying to find the factors that cause or prevent cardiovascular disease. All right, the bottom line, the researchers found a negative association among males between the amount of daily physical activity and the occurrence of cardio disease. What conclusion can be made? Answer A, the results suggest that an increase in physical activity may cause a reduction in the risk of cardio disease. Okay, see, A has that word cause. We cannot do cause and effect with an observational study. So it's not going to be answer A. B suggests there is a positive correlation between high physical activity and low risk of cardio disease. Maybe, okay, because here they just say a correlation. They didn't say cause. All right, so it's maybe B. I'll leave B alone. C, the results suggest there's a positive correlation between high physical activity and low risk of cardio disease among males in Framingham. Okay, that's better, because this said among males, okay? So this one says among the people, this one says among males, so that's much better. I'm thinking it's C. D, the results suggest that males who work out 2 hours a day don't have any risk. That's baloney, okay? This is very specific, working out 2 hours a day. Nowhere in the study did they suggest that. All right, and just to refresh your memory, negative correlation or negative association, that means one variable increases when the other one decreases, okay? So basically, amount of physical activity increases and cardio disease decreases. Or you can say it the other way around, but it's basically a negative slope, all right? So that's it. That's it, answer C. All right, Florida Bartfast, the king of so-and-so, was an exceptionally tall man. He had a hypothesis that there's a positive association in the land between the length of a person's first name and their height. He ordered his servants to collect info about each and every person in the land regarding their height and the length of their first name. Then he analyzed the results and looked for trends in the data. Okay, so since he did each and every person in the land, it doesn't seem to be a sample to me. Okay, and no one was administered a drug or anything like that. So it's not an experiment. It's once again an observational study. All right. And they didn't say anything about cause and effect. It was just he had the hypothesis that there's an association between length of the person's first name and the height. So it's an observational study, and is this appropriate for the question it's supposed to answer? All right, it says yes, because he adequately gathered relevant data. I think that's correct. All right. Here it says he didn't use randomization, but you don't really have to use randomization for an observational study. Study doesn't show whether name affects the height. We didn't say effect. We just said a positive association. We didn't say effect. So it's not C. Hypothesis doesn't make sense. That's true, but I don't know. I'm going to go with A. If it's not A, I think it's D. Okay, like we said, the study doesn't show whether the name affects height. Observational studies can never suggest causation, only correlation. But his hypothesis was about correlation, so there's nothing wrong with an observational study. Study doesn't use randomization. Data was collected about all citizens, so no randomization was really needed. All right, randomization is done to rule out the effect of other parameters to establish causation, which we know wasn't the goal of the study. The hypothesis may not make sense, but that's irrelevant. Researchers interested in assessing the effect of medication on work stress. They randomly assigned 200 full-time employees to two groups. One was instructed to meditate 10 to 20 minutes twice a day and to participate in weekly 1-hour sessions. Other group wasn't given any special instructions. All right, I can tell already this is an experiment. See how they had the two groups, and the one group they did meditation, and the other group did nothing. All right. Just before the randomization is also after a period of 8 weeks, all participants were required to fill out the questionnaire, an accepted measure of work stress. The researchers calculated the difference in questionnaire scores for all participants where a positive change corresponds to a reduction in work stress. Then they compared the average differences. All right, so this is definitely an experiment. They applied the meditation to one group and not the other. The researchers found that the mean change in scores of the group who meditated is 21 points greater than the mean change in scores of the group who didn't. Based on some re-randomization simulations, they concluded that the result is significant and not due to the randomizations of the groups. What valid conclusions can be made? Okay, answer A says the results suggest meditation can reduce stress, but B says same thing except specifies work stress. All right, so I think that's much better because this was based on work stress. All right, and the questionnaire they did was an accepted measure of work stress. So I'm definitely not going to choose A because it just says stress. B says work stress. I'm thinking that's it. All right. It just says can reduce work stress. It doesn't say it definitely does. C talks about a correlation between meditation and work stress. However, when you do an experiment, that's for cause and effect. Okay. That's not just for a correlation. When you do an experiment, that's for cause and effect. So I think it's B. D says it very matter-of-factly, all right, and I don't like that because there can definitely be other factors in the study here. All right, so I'm going to go with B. Okay, their answer: in an experiment, one parameter of the population is actively changed, and meditation regimen was actively assigned by the researchers to each subject. All right, and the other group, they did nothing, so it's a good comparison. All right, randomized experiments are designed to suggest causation or cause and effect. Okay, the randomization of the subjects between the groups was intended to smooth out any factors other than meditation that may affect work stress. Therefore, it's valid to conclude meditation can reduce work stress. It's also valid to conclude a positive correlation, but correlation is weaker than causation, okay? Remember, I said for experiment, it's supposed to be cause and effect. So if causation can be concluded, it is more suitable than correlation. All right, even though experiments suggest causation, it's too far-reaching to conclude meditation reduces work stress. All right. And it's wrong to conclude that meditation reduces stress in general. Remember, we said work stress, not just regular stress.